In example number 2, I would like to give several examples of how to verify trigonometric identities. Verifying a trigonometric identity basically means that you have an equation, such as this one, and you want to see that this equation is true. Is it true that these two sides are actually equal? They look very different, but I'm saying in this equation right here that these two things are actually exactly the same. Is that true? Well, verifying a trig identity means check that this is true. Check. How do you do that? Well, usually you just start with the side of the equation that looks the most complicated, and then you work on that side by simplifying it one step at a time until you get to the other side. In this identity that I have right here, the side that looks most complicated is definitely the left side. That looks a lot more complicated than the right hand side. So the idea is then to start with the left hand side and just simplify, just like we did in the previous example. Try to simplify this until we get to the right hand side. And like I said in the previous example, there's usually more than one way of doing this. Okay, I can think of at least 3 ways right now off the top of my head in which I could simplify the left hand side to get the right hand side. I'm gonna do 2 because 3 I don't want to do like every single possible way ever, but I think with 2 ways of showing you, it will drive home the point that I've been trying to make, and it is there's more than one way of doing this, and you should be able to think of something and try something, because usually doing something might lead you to the solution. Think what is one thing that you could do with this one. Starting with the left hand side, what is one thing that comes to mind that you could possibly do to simplify it? One way is the numerator actually kind of reminds me of trigonometric Pythagorean identity. And indeed, there is a trigonometric Pythagorean identity that has a secant squared and a 1. And what is that trig Pythagorean identity? Well, it is 1 plus tangent squared of x equals secant squared of x. That's one of the 3 Pythagorean identities. Now, if you move the 1 to the left-hand side, what would you get? You would get that tangent squared of x equals secant squared of x minus 1. But that is precisely the top right here. The top is secant squared minus 1, so this equation right here tells me that the top is actually tangent squared. So that's one way we can start this problem. So let's do it. So the left hand side, I'm just going to copy it here for my convenience, is secant squared minus 1 over secant squared. But this right here tells me that the top is actually tangent squared. So we get tangent squared of x over secant squared of x. Okay, now, what else? Well, tangent squared of x, dividing something is the same as multiplying by the reciprocal. So dividing by secant squared is the same as multiplying by the reciprocal of secant squared. Okay, dividing by something is the same as multiplying by the reciprocal. So dividing by secant squared is the same as multiplying by the reciprocal of secant squared. Now, the secant is the reciprocal of which one? If you said cosine, then you got it right. So, yes, secant is the reciprocal of cosine. So, cosine and secant are reciprocals of each other. So, if I'm talking then about the reciprocal of secant is just cosine. All right, so then this means that this is cosine And because it's squared, it's cosine squared. So you get tangent squared times cosine squared. And finally, note that the goal here is to get to sine squared, so we're not really there yet. But even if we didn't know that that's our goal, you still realize there's a little bit of something that you could do here, because you can write tangent in terms of sines and cosines. And writing tangent in terms of sines and cosines, you would get tangent is sine over cosine, but it's squared, so it would be sine squared over cosine squared. And now you can cancel these and get sine squared of x, which is actually what we wanted. That's what was our goal, to show that the left-hand side is actually equal to sine squared. And that's what we got. So that means the equation, the identity has been verified. Okay, so that's one way we could have started. Now let's do it a different way now. So let's call this one method 2. What other way could we have started on the left-hand side to get here? Well, because the bottom is actually only one term, we could actually split that up into two pieces. Remember that when the bottom of a fraction like that is only one term, such as, let's say if you have something like this, a plus b over c, you can split that up and say this is a over c plus b over c. You can split that up like that. That means a over c plus b over c. So that's another way we could do it, because the bottom is actually one single term here. We could split that up. So let's write down what we would get. We have, secant squared of x minus 1 over secant squared of x. Splitting that up, we would get this over that. So you would get secant squared of x over secant squared of x minus 1 over that. Minus 1 over secant squared of x. Now, secant squared over secant squared, that cancels, and that gives you just 1. Okay, and this one says the reciprocal of secant squared, which we already talked about it right here. The reciprocal of secant is the cosine. Secant and cosine are reciprocals of each other. So you would get here that this is cosine, and then because it's squared, it would be cosine squared. And now, that should remind you, you see a cosine squared and a 1, that should remind you of the Pythagorean identity, which is what? It is cosine squared of x plus sine squared of x equals 1. So if you have 1 minus cosine squared, that's precisely what would you get if you move that over there. You would get sine squared of x equals 1 minus cosine squared. So that means that this thing right here is sine squared. So this is sine squared of x. And we got, again, the same thing as before. So that was another way of arriving at the same place. And like I said, there's even more ways of doing this, but 2 different ways illustrates the point. Okay, so now let's do another example. Okay, let's verify this trigonometric identity. Again, we just think of this as an exercise in simplifying a trigonometric expression. You start with a more complicated side, which is obviously the left one, and simplify, simplify, simplify until you get to the right-hand side, which is 1. Okay, once again, there's more than one way of doing this, and I'm gonna do it 2 different ways. So let's call this one method 1. So think about it for a second. What is one way to start this. Well, just like before, those things right there, the 1 and the cosine squared and the 1 and the cotangent squared, that should remind you of trigonometric Pythagorean identities. Okay, there's one that has a cosine. Let me write it down. Cosine squared plus sine squared equals 1. And the other one, the other Pythagorean identity that has a cotangent is 1, or we can say cotangent squared plus 1 equals cosecant squared of x. So actually then, this right here, 1 plus cotangent squared, is the same as this. The order in which you add things doesn't matter. So that means this parentheses, this entire parentheses, is the same as cosecant squared. And 1 minus cosine squared is actually sine squared. From this one, if you move the cosine squared to the other side, you will get that sine squared of x equals 1 minus cosine squared of x. So actually then, using these two things that we got right here, this one and that one, we can use that to replace these things, and let's see what we get. We get 1. I'm going to copy the left-hand side again for my convenience. So this is what the left-hand side is. Okay, so what? So 1 minus cosine squared is actually the sine squared. So we can replace that with sine squared. And 1 plus cotangent squared is the same as this. Okay, the order is different, but it's the same. And that is cosecant squared. Okay, that's better. And now finally, you can think, okay, what now? Well, the cosecant is the reciprocal of sine. Yeah, it is the reciprocal of sine, and because it's squared, it will be sine squared. And now look, these two cancel each other. And what do you get? You get precisely 1, which is what we expected. So the identity has been verified. It's true. The left-hand side equals the right-hand side. Okay, so that's one way in which you could have simplified the left-hand side, in which you could have done this problem. Now, is there another way you would have done this? Another way we could have done this is by changing just one of these. So instead of just changing both of them like we did here, let's see what we would get if we just change only one of them. Let's say this one, the first one. So let's call that like method 2. It's the second way of doing this. Okay, so let's assume we just changed one of them. So using cosine squared plus sine squared equals 1, so that means sine squared of x equals 1 minus cosine squared. Let's change just the first one and work with that. So that means we have 1 minus cosine squared of x, 1 plus cotangent squared of x. Okay, then changing just the first parentheses, that is actually equal to sine squared. Okay, now let's see. If we just change the first one, what do we do now? Well, we can distribute this, and let's see what we get. Distributed, you would get sine squared times 1, well, that is just sine squared. And sine squared times cotangent squared, let's write that down. That is sine squared times cotangent squared. Now, cotangent squared, that is actually cosine over sine. Cotangent is cosine over sine. And then because it is squared, you would have to put both of them squared. So, cotangent is cosine over sine. But because it is squared, you have to put squared for both. And now, note what happens now. You can cancel that. What do you get? You would get sine squared plus cosine squared. But what is sine squared plus cosine squared? That is actually 1. So the identity has been verified again. We ended up with 1 as well. Okay, so you see, we did it slightly differently and we still got the same answer. Okay, let's do this example now. I strongly encourage you to pause the video and attempt this one on your own. So to verify this trig identity, so start with the left-hand side, which is the side that looks the most complicated, and see whether you can simplify it to give you the right-hand side. Okay, so assuming that you gave that a shot, let's do it. So this is one of those where you have only one term on the bottom, and we did something like that already before. Remember when I showed you this trick? When you have only one term on the bottom, you can split it up. So that's one way to start. One way to do this. We're going to use that trick here. Okay, so splitting this up, that means tangent over sine plus cosine over sine. All right, and well, cosine over sine is, so leaving this one intact, not doing anything to that one yet. Cosine over sine is cotangent. And now we're almost done because you see I'm supposed to end up with secant plus cotangent, and I have this plus cotangent. So I have half of this. So this thing better be secant. So let's simplify it. How would you simplify that? Well, change the sign, well, change the tangent, change the tangent to sine over cosine. So we would get sine over cosine, that's the top. All that over sine. Okay, now dividing by something is the same as multiplying by the reciprocal. So dividing here by sine of x is the same as multiplying by 1 over sine of x. So it's the same as multiplying by 1 over sine of x. Okay, and now you see that we can cancel the sign. And we get 1 over cosine of x plus cotangent of x. Now 1 over cosine, the reciprocal of cosine, is the secant. So this is secant of x plus cotangent of x. And that is precisely what we wanted. We wanted to end up with secant of x plus cotangent of x. So we simplified it to what we wanted. So the identity has been verified. Okay, now let's look at this next example. Verify this trigonometric identity. Okay, always start with simplifying the side that looks the hardest, the most complicated one, and then this one is the left again. So our job is just to simplify the left-hand side and see that we get the right-hand side. Okay, it does look complicated, but actually it's not, because whenever you see a pi over 2 minus x inside a trig function, that should remind you of the cofunction identities. That is one of the cofunction identities, and that's what you should use to simplify this. And here it is. the cofunction identities, well, this one right here. Cosecant of pi over 2 minus x equals secant, because cosecant and secant are cofunctions of each other. Secant and cosecant are cofunctions. So actually then, the left-hand side this base right here, I can pass to the cofunction into the complement, so that would be secant of x. That is secant of x, and then I still have the minus cosine of x. Okay, that's looking a lot better. Now, what can you do now? Well, secant, you can remember that that's 1 over cosine, and that might help. So let's write it down. Secant is 1 over cosine. Okay, yes. And now, well, now we can try to put this into a single fraction, because we have, you see, looking at the right hand side, you see that that's a single term. So two things multiply together. So one thing is we can simplify this by just writing the whole thing as a single fraction. So to do that, imagine this one as being over 1, and then I want the common denominator. The common denominator would be the cosine. To get a cosine here on bottom, you would need to multiply by cosine top and bottom. So then this would become what? This would become 1 minus cosine of x, and then this one right here would become cosine squared of x over cosine of x. And now that they have the same denominator, we can put it together in a single bigger fraction, like this. So same denominator, so just subtract across. Okay. And now 1 minus cosine squared should remind you of the Pythagorean identity. This one that we have used over and over. Okay, when you subtract cosine squared and move it to the other side, you get 1 minus cosine squared is sine squared. So 1 minus cosine squared is sine squared. So this becomes sine squared over cosine of x. And we're almost done. See, I want here to end up with sine times tangent. So this actually, you can simplify this by just borrowing a copy of sine and say, okay, this is what? This is sine times sine, because sine squared is sine times sine. Sine times sine over cosine of x. So I kind of borrowed one of the signs here, pull it out, factor it out. And then this, now this part is tangent. So this would be sine of x times tangent of x, which is precisely the right hand side. So we simplified to what we wanted. Okay, so this problem, what I want you to take away is that if you see a pi over 2 minus x inside of one of the trig functions, that should remind you of the cofunction identities. And another thing is, if you have two terms, one way of simplifying that is to perhaps put them together in a single fraction like we did here. That also could help when simplifying. All right, and here's the last example. This one is a technique, and it's a technique of multiplying by the trigonometric conjugate. So this is what you do when you deal with complex numbers, and so you learn that in college algebra, and when rationalizing denominators, you multiply by the conjugate. So here, there's a technique that, for simplifying trig expressions, that works similarly. So what is a trigonometric conjugate? Okay, let me remind you real quick. For complex numbers, if we have like 5 plus 3i, the conjugate of that, if you remember the notation, is the conjugate is you put a bar over it. The conjugate of that is 5 minus 3i. This basically is the same thing, but you change the sign in the middle. So that's that. When you were rationalizing, what is the conjugate of that? Well, that would be when you multiply, rationalize. You multiply by this, right? So in context, if you wanted to simplify this, you multiply top and bottom by the conjugate. Okay, I'm not going to do it, but just to remind you, that's what you learn in college algebra. And if you wanted to rationalize this, what do you do back then in college algebra? You multiply by the conjugate. So, because that's for simplifying. So, a similar trick holds here. If you have a trig rational expression like this, one thing that works is to multiply by the trigonometric conjugate. So, let's do it here. So, I have cosine of x over 1 minus sine of x. The thing is, like, there's really nothing that we could do right now to simplify this except this trick. Starting with the left hand side, sometimes this is the only thing that works. So let's multiply by the trigonometric conjugate would be this. It's the same thing, but you change the sign in the middle. Okay, let's see what we get. I want to show that when I simplify this left hand side by doing this, I end up with the right hand side. Okay, what is this? This is, well, the bottom would become 1 minus sine squared by foiling the bottom, and the top would be cosine of x 1 plus sine of x. Just multiplying across. Now, 1 minus sine squared, again, that's the trigonometric Pythagorean identity. So that is actually cosine squared. And now note that you can cancel one of the cosines. And what do you end up with? You end up with 1 plus sine of x over cosine of x, which was the goal. Okay, so that's one last trick that you could use to simplify trigonometric expressions. If you have a fraction like this, a rational expression of trig functions, one way to try to simplify it is to multiply top and bottom by the trigonometric conjugate. And it doesn't have to be the trigonometric conjugate of the bottom. I did the bottom in this one because I started with the left hand side, and the bottom is the one that has two terms. But if they had given me the right hand side instead, then you can multiply by the trigonometric conjugate top and bottom of the top, because the top is the one that has two terms. Okay, and if you do that, if you start with the right hand side and apply this trick, multiply by the trigonometric conjugate of the top, then you actually would end up with the left hand side.